Let's say you're given a graph that has an original image and a rotated image, and you're asked, what is the degree of rotation? What you want to do is pick some of the key points on your original image, those corners, those vertices, and come up with the coordinates of those corners. Then you want to find the corresponding points on your rotated image and the coordinates of those, and then compare them and see which of these rules was applied. So let's say you're looking at your graph and this is point A. These are the coordinates of point A. You know that this other one, 4, 3, are the coordinates of the corresponding one because it also has A, but it has a prime symbol. So A became A prime. So let's look at these and see how they changed. A is our XY. Notice that the 3, our X coordinate, is now in the Y coordinate spot. So that's now the second number we see. And the -4, our Y coordinate, is now in the X coordinate spot, but it's now positive. It's the opposite sign. So it's the opposite of Y. So which degree of rotation occurred? Right here. And also right here. We can describe this rotation as rotating 90 degrees counterclockwise or 270 degrees clockwise. Why is that? I'm going to illustrate this on a simpler example. If this is our original point and we rotate it 90 degrees counterclockwise, remember each of these quadrants is 90 degrees. So 90 degrees counterclockwise would get us right here to this point. Now we could have also gotten to that same exact point by going 270 degrees in the opposite direction. 90 plus 90 plus another 90 is 270. So it's just a different way of describing it and getting to that same point. Let's look at this one. Notice the 3 is in the same spot. The X coordinate is still first, but it's the opposite sign. It was positive, now it's negative. So X becomes the opposite of X. And the same with the Y coordinate. -4 now became +4. So it's the opposite of Y. So if you look at our table here, we see that this has rotated 180 degrees. And you can say clockwise or counterclockwise, you still get to that same exact point. That is, if our original point was here and we rotated it 180 degrees counterclockwise, we go 90, 90, end up right here. We could have also gone 180 degrees clockwise, 90, another 90, and ended up in the same spot. That's why it doesn't matter if you say clockwise or counterclockwise. How did this change? Notice our X, Y, they switch spots again. So our X is now in the second spot, but now it's the opposite sign. So it's the opposite of X, opposite sign of X. And our Y is now first, and it stayed that same sign. So which one is it? This one or this one? You can say it rotated 90 degrees clockwise or 270 degrees counterclockwise. So again, if our original point was here, we could have gone 90 degrees clockwise and ended up right here, or we could describe it as 270 degrees counterclockwise. So 90 plus 90 plus another 90 is 270 degrees clockwise. So that you end up in the same spot, you're just describing the rotation slightly different. How about this one? What do you notice? The XY didn't change. What does that mean? It's not listed here as a rule. Let's think about that. We go back to that original point here. How many degrees do we have to go if we go clockwise to get back in that same exact spot? We go 90 plus another 90 90 plus another 90. We go 360 degrees clockwise. Or you could say 360 degrees counterclockwise. Same thing. So if your coordinates stayed exactly the same, your figure ends up in the same exact spot, you have rotated 360 degrees all the way around.